Hi everyone, my name is Digvijay and welcome back to my YouTube channel Pick Up Pencil. In last video we learned that Java is an object-oriented programming language, and now in today's video we are going to learn about object-oriented programming concepts, and those concepts are abstraction, encapsulation, inheritance and polymorphism. So these object-oriented programming concepts are really a powerful way by which we can build a secure, a reusable and very easy to write code application. So as this name suggests, right, object-oriented. So object-oriented means in Java, programming language like Java or Python or C# or C++, everything is object, and the whole development of the project and the system happens on the basis of object. You will be managing objects all around. So that is why we wanted to look at the bigger picture today, the idea behind these object-oriented programming concepts. So now we are keep talking about the object a lot of time, right? So before really jumping into these concepts, I want to take a moment to really understand what object really means. Okay, so if you talk about an object, right, so object is nothing but an entity. So entity, or we can say in the real world, right, we see a lot of objects around us, like a house, a whiteboard, a car, a person or a pen. So everything around us is an object. So similarly in the programming world, we divide our system into those entities which are called objects. And likewise in the real world, the objects has some properties and behavior. Like for example this pen, right? So this pen has some property, like this has a color green and the behavior may be writing. So similarly each object in the programming language will have some properties or some behavior. So object is something that consists of property plus behavior, properties plus behavior. And a lot of time people keep using whole different terms about the properties and behavior, and some people says like data plus functions. So properties and behavior is similar data plus functions, or some people says data values. So all these terms mean the same thing. So object is something that consists of properties and behavior, or object is something that consists of data plus functions, or object is something, any entity that has some data values. And similarly there will be many objects in a bigger program when we think about building a system. So now we are clear about object in a conceptual ways. Later on we'll be doing some programming on this, but in today's video we wanted to understand everything at a high level, at a concepts level. Now since we already have a basic idea about the object, now quickly jump upon the first object-oriented programming concept, and that is abstraction. So basically abstraction is an act of presenting only the essential functions and not letting know that's what's happening really in the background. So when we achieve an abstraction in our programming, that means we are only showing the required functionality but really not showing how did we actually do it. So that is why this abstraction focuses on what, not how. So it focuses on what this piece of function is doing, but doesn't show it up that how does it actually doing it. So this adds up a big, you know, advantage of security in your data and your programming, whatever you are doing. So that's why. And if you take an example of this in the real world, right, abstraction, we see it in many places. Let's take an example of, let's suppose an example of car. So if we see, right, so car, again, this object, we can consider this an object, and we can say, like, you know, car has a function of rotating tires. Now we see that the car is, you know, able to rotate the tire, and maybe there is some other object which is calling it, let's suppose the engine, which is actually sending an instruction to tires to have them rotated. So they are being rotated, but how they are actually being rotated, that implementation is something happening in the background, or it's totally hidden from the end user. So that is why the abstraction is a way by which we are able to secure our data members in such a way that we provide only the required details and does not give them an idea that what is really happening in the background. So that was all about abstraction. Let's move on to our next object-oriented programming concept, and that is encapsulation. Second concept of object-oriented programming language is encapsulation. So in one of the last videos, we have seen that the biggest advantage we get in object-oriented programming language is that there is no free flow of data within the functions, and we achieve that benefit through encapsulation. So basically, encapsulation is a way by which we restrict the free flow of the data among the functions, and we wrap the data and the methods or the functions as a single unit, so that the data is private to the unit and no other outside world entity can really have a direct access on the data members. So let's learn it with the help of a quick diagram over here. So let's suppose we have an object 1 over here. Okay, so this is object 1, and this is object 2, and let's take one more object called object 3. So what we are trying to really learn here, that how does encapsulation happens in an object-oriented programming world. Okay, so we have just taken the 3 objects here, and we have already learned that object has its data and its own data and its own function. So similarly, each object has its own data and function. Okay, this object 3 has its own data and its own function. So we have already learned that there is no free flow of data among these objects over here. So what we are actually doing here, in each object, we are wrapping each of these objects within its own unit. So we can call this as a one unit, another unit, and there is one more unit. So we have wrapped up this object with its own data and the function. So that's basically what's happening here is the data, whatever data is here in this unit or in this object, this data is only accessible by the function. This data is only accessible by the function, and only this function can change the data. Similarly, this data is private to this function, and this data is private to this function. So that is why this is really a powerful way, because when we talk about the bigger world, when we have the hundreds of thousands of functions, so each function, the another function, now if I talk this data, right, this data cannot be changed by another function, because this can only be changed by this function. And when we need to interact among the objects, let's suppose this object 2 wants to communicate with object 1, so it can only communicate through the functions. It can call the functions, but this function 2 cannot change the data here. It can only make a request and execute this function, but changing the data members is only can be done by this object itself. So that is why we have restricted the free flow of data among the functions, and this is how we have incorporated a greater amount of securities. So all the data is private to its object, its own unit, but not for the outside world. So this is how step by step we are learning that in object-oriented programming language, it's providing us that way where we can be very restrictive, and our software is not something that is vulnerable for the outside world, and anyone can change the values. So that is why these programming languages, these programming concepts, especially encapsulation, is providing a great amount of securities here. Okay, so next, the third object-oriented programming concept we are going to learn, and that is inheritance. Inheritance is one of the very important concept of object-oriented programming language, and when you start developing your code, believe me, you will be using inheritance at every step of your programming. So basically, inheritance is a way by which we inherit something from someone else. We do not really develop it, but we inherit it from someone else. Let's take an example, like a person, like me. Maybe I have inherited something from my father, and maybe something from my grandfather too. So that is how an act of acquiring something from someone else is called inheritance. So even in the programming language as well, it is not necessary that when you build a class and you create an object, it is not necessary that you should be developing every single thing in your class. No, if something is available already within your environment and you have access to it, you can go and inherit those properties and behavior into your object. So that is what the concept is. Let's take a quick example here so that this concept is even more clear. So we are keep talking about car object. So let's take car object over here again. So let's suppose we have a class here, car, right? And here we have some methods, some functions over here, like, okay, let's take this rotate tire, a function of car. Okay, so car is a class here, right? And then another one we have maybe play horn function and start engine. So these are the basic qualities or the properties of a car we expect, right? If we expect a car, if we see a car, the car should be able to rotate a tire, car should be able to play horn, it should be able to honk, or it should be able to start an engine. So this is, maybe we can call a broader class, car. Now there is one more class, and later on, right now we are talking about the car, but in order to act on these properties and behavior, we create objects. Okay, so now another class, let's suppose we take Honda. So now Honda is again a car. So what we are doing is, Honda is going to inherit the properties and behavior from the parent class car. It is going to extend the Honda car is going to extend car class, and that is how Honda is going to access the properties and the method from the parents class, which is car. So now if I talk about what all Honda car has. So Honda car, so after inheritance from the car class, now Honda class has the access of all these methods. The Honda class already acquired all these behavior, all these functions, all these data values from the car class. Plus, it may be possible that your own class may have some specific functionality that is not present in the car you are extending from, you are inheriting from. So what you can do is you can declare your own functionality here. Maybe Honda has some specific feature, maybe this open sun roof. So this Honda car has some feature to open a sunroof for the car. So now after extending from the car class, after the inheritance from the car class, Honda class has acquired all these properties. Now Honda car is able to rotate tire, it's able to play horn, it's able to start engine, plus it has its own feature to be able to open a sunroof. So this is why it's a great programming feature of an object-oriented programming like Java, where you have a big reusability of the code. Think about if this inheritance function concept would not have been there, we will end up writing all these functions again and again here. And let's suppose there is one more class called Toyota. Now again, Toyota can again extend from the car class, and all these properties and method will be directly available here. And then again, Toyota can have its own specific functions here as well. So that is why in this way we achieve a big reusability of the code. Instead of repeating the code again and again, if something is common, the class can extend it, class can inherit from the parent class, and that is how inheritance works in Java. So now after this we are going to move our last object-oriented programming concept from today's video, and that is polymorphism. Fourth and the last concept of object-oriented programming language is polymorphism. So polymorphism, as the name suggests, it's basically a combination of two words. One is poly and second one is morph. So poly means many and morph means terms. Many terms. So with the help of object-oriented programming concept like polymorphism, we will have an ability to have our function acted different in the different situation. So basically there will be just one function, but that function will be acting different in the different situations. So polymorphism in a regular terms, right, we also get if some single word is getting treated different in the different situation. One word we know that one is duck. So we know that duck is also a bird, and duck is also in cricket. If a batsman gets out without scoring anything, that's also called duck. So we see that the bird and the cricketing term, it's totally different, but this word is able to solve the purpose of acting differently in the different situation. So similarly, in the programming world, we can make our functions to act such a way so that on the basis of the arguments, now in the programming term, on the basis of argument, they can behave differently. So I want to take a quick example over here. Let's suppose I have an object area, a class area, okay, and it has a function calculate area. So function calculate area. Okay, so now the same function, what I'm going to show you here, how the same function calculate area is going to act differently in the different situation. So let's suppose we want to calculate an area of a rectangle. So calculate area of rectangle, we will need length and breadth. Okay, so we'll need int like length and int width. So in order to calculate the area of a rectangle, we need length and breadth, and then we can say area, and then area will be length into width, right? So this is how. Now think about the same function calculate area. We can use it in order to calculate an area of a square, not rectangle this time, but the square. So what we really want, we really do not want these two parameters. We just want one parameter, that is int like side, right? Because we know for the square all sides are same, and then area will be side into side. That's all. So now see here, this calculate area function is the same function. We did not change the name of the function. Same function will be behaving differently while calculating the area of rectangle, that is length into width, and behaving differently while calculating the area of square, which is side into side, like side square, or we can say side square here. So that is how here, and this terminology, especially in the programming, this is called method overloading. So remember this, whatever we just did right now, having an ability of a function to behave differently in the different situation with the help of different argument, we were able to make it polymorphic, and we did it through the method overloading. Whatever we just did, that is an example of method overloading. So this is how we achieve polymorphism in object-oriented programming language. So from today's video, I hope conceptually it will be a clear for you guys to kind of get the high level idea on the bigger picture about the object-oriented programming concept, that abstraction, encapsulation, inheritance, and polymorphism. And when we deals with the object, think about a scenario where you are dealing with the multiple functionalities, hundreds of objects. In that situation, all these programming fundamentals will be very handy, and everything you will be doing as per these programming concepts. So I hope you enjoyed watching today's video, and if you like the video, you can share it, you can subscribe it, and you can send this link to your friends, whoever are interested in learning the programming language like Java. Thank you.